Hello dear students. So in this video we are going to discuss about the standard hydrogen electrode. Okay, and in short it is written as SHE, she. Now first of all I will give a intro that why we need to study this standard hydrogen electrode. Okay, what is the necessity? Now you see students, as we talk about the electrode potential, okay, so it is not possible for us, say if you just remember the this galvanic cell which I explained in my previous video. Okay, so there you have seen that there were two half cells. Okay, there was the two half cells were there. Okay, one was the where the zinc electrode were there, and in the another half cell the copper electrode was there. So here oxidation took place and here reduction. Okay, now say, and already I have said you that electrode potential is generated at each half cell, right? Because there is a separation of charges, right? So say, so it is possible for us to connect these two electrodes and find out the change in the potential difference, right? It is very much possible. Already we have seen how we take out the potential difference between these two electrodes. Okay, that is the oxidation half cell and the reduction half cell. Now say we only want to find out the electrode potential of these half cell. Okay, or say we want to find out the electrode potential of this half cell. Okay, then how do we find? That means what I am trying to explain you that see, change in potential difference though we can find out very easily by connecting the two half cells. Okay, and we can find out the change in the potential difference, right? That you agree. But if individually, if we want to find out the electrode potential of any one half cell, okay, individually, then it is not possible for us to do that. Say I want to find out what is the electrode potential of zinc, और what is the electrode potential of copper individually. ठीक है, चेंज तो निकाला. ओके, चेंज तो निकाल लिया ऑलरेडी सर्किट बना के, जैसे इलेक्ट्रोकेमिकल सेल्स में वी हैव ऑलरेडी सीन. ठीक है, दोनों को कनेक्ट करके. लेकिन से कि वन इज नॉट देयर, say this copper is not there. Okay, this half cell is not there, only one half cell is there, and we want to find out the electrode potential of this half cell. Okay, so how we find out? See, electrode potential of any half cell, you can just note down. Okay, electrode potential of any half cell is not possible to find out individually. Okay, I'll repeat that the standard electrode potential of any half cell, okay, only one half cell, individually cannot be taken out. Why? Because why? Because when I talk about the electrode potential, okay, so there should be, because we are talking about the redox reactions, already I have told you. So there should be oxidation and reduction as well. So if we take only one half cell, if we take only one half cell, what do we see? That it is not possible in the one half cell that oxidation and the that means the redox reaction is not taking place. And once the redox reaction is not taking place, what will happen? You cannot find out the this electrode potential of the cell, because you can see that here the circuit is not completed, okay, and once it is not done, you will not get the change in the charge, I mean the difference in the charge, the separation of the charges how you were getting because of these uh, what, electrons, right? And once this circuit is not completed, once the reduction half cell is not there, what is happening, the reaction, the redox reaction which was set earlier is not is now it is not there, okay, and once this redox reaction is not there, you cannot find out the potential difference, okay. For finding out the potential difference, or for finding out the electrode potential of any one half cell, you need the another half cell also, okay. That's why it is said that individually you cannot find out the electrode potential of any one half cell. And that's why to solve this problem, because we need to know the electrode potential of every metal, okay. To solve this problem, the standard hydrogen electrode is introduced, okay. So standard hydrogen electrode, it act as a reference electrode. See, already I've said, you say I have the zinc electrode here, okay, and here it is the zinc electrode dipped in the zinc sulfate solution, okay, and I want to find out the electrode potential of these half cell. So already I've said you individually you cannot find out. So what I will do, because I need both the half cell, already I've said you. So what I will do, in the right hand side I will take this standard hydrogen electrode. Okay, because single akele you cannot find out the electrode potential of this zinc electrode. Okay, so we need one reference for that, and that reference is this standard hydrogen electrode. So what does it do? We will put the standard hydrogen electrode on as a cathode because it is already acting as a anode, okay. So this standard hydrogen electrode will act as the cathode, okay, and I'll explain you how this is set up, this standard hydrogen electrode. So what will happen, then we will connect these two electrode and then we can get the change in the potential difference. Remember students, it is not possible, yes, yes. So so I'll tell you how. So this standard hydrogen electrode, no, which we are taking as a cathode, okay, to finding out the electrode potential of this zinc, okay. So the electrode potential of this reference standard hydrogen electrode is arbitrarily, okay, at standard conditions it is kept at 0 volt. This is a very important point, you can just note down, okay. So the standard hydrogen electrode, first of all, it acts as a reference electrode. Reference means it can be used with any other electrode to find electrode, okay. And the second point is that the electrode potential, standard electrode potential of the standard hydrogen electrode is always, by definition, it is kept at 0 volt, okay. So once this is a 0 volt, the electrode potential, once if this is a 0 volt, so whatever deflection we will get in the voltmeter will be the electrode potential of this zinc electrode only, okay. So I'll come to this point slowly. So we will see the construction of the standard hydrogen electrode, okay. So for making up the standard hydrogen electrode, in a beaker we take a platinum wire. So this is the platinum wire, okay. So you can see it is this platinum wire, okay, this thin wire, it is sealed in a glass tube, okay, it is sealed in a glass tube. And this one, it is very important, this this plate, no, this is a platinum foil, okay, a platinum plate, and the on this plate the platinum metal, finely metal is coated, okay. So in on this is a platinum plate, platinum foil you can say, and on this foil the platinum metal, very fine divided powder of platinum metal is coated, okay, and these acts as a catalyst. So catalyst, you know, it uh, enhances the reaction rate, right? And this is this is all, and this is the inlet. Okay, this is one inlet is kept. Through this inlet hydrogen gas is bubbled, okay, at the pressure maintained is 1 bar pressure. Okay, these conditions are very very important, that the hydrogen gas which is bubbled through this platinum wire is maintained, the pressure is 1 bar pressure. Okay, and the concentration the solution which we take in this beaker, okay, it is 1 molar H plus. I mean, we take HCl solution, any solution you can take, any aqueous solution where you get H plus ion as a yes, H plus ion you get. So if you take it, normally HCl solutions are taken, so here the concentration of H plus should be 1 molar. Okay, so once we take HCl solution 1 molar, so the concentration of H plus ions, because HCl will get dissociated into H plus and Cl minus, so there will be concentration of 1 molar H plus ions in the beaker, and that is very needed. Okay, so and the temperature is maintained at 298 Kelvin. So the conditions are very important. Temperature is 298 Kelvin, pressure is 1 bar pressure, and the concentration of the aqueous solution or the ion is 1 molar. Okay, these three conditions are maintained for this setting up of these standard hydrogen electrode. Students, you have to you should know that platinum, it is an inert electrode. Inert electrode means what? It do not take part in the reaction. Okay, this platinum electrode, like you have seen zinc rod, when we were talking the galvanic cell, it took part in the oxidation process. That means it took part in the reaction. That means the zinc is an active metal, reactive electrode. It is not inert, but platinum, it is an inert electrode. Cannot it do not undergo reaction. Okay, it do not take part in the reaction. Only what it does, it gives its surface, it allows its surface for acting as a catalyst. वो अपने surface को reaction होने के लिए allow करता है. That means oxidation and reduction which will take place on this surface very easily. So this platinum surface, it do not take part in the reaction, but it allows its surface for the reaction catalysis. Okay, it catalyzes the reaction. So this point is also important, that the inert platinum electrode, it enhances the rate of the reaction. It supplies the surface for the reaction to take place. Okay, because the hydrogen gas which will pass through this platinum electrode will get absorbed. You will absorption, you will learn in chapter 5, but absorption is, in short, you just understand like this, that when we ink, what happens, the molecules of that ink get stick to the chalk. Okay, that is adsorption. Like that only hydrogen gas, when we will bubble through this platinum wire, so this hydrogen gas will be attached on this platinum surface, and this is necessary for the reaction to take place, because we will see that oxidation and reduction how it will take place. So this platinum surface gives a room for the reaction to take place on its surface. Okay, so now, so this was all about how it is made. Okay, how this platinum electrode is constructed, the standard hydrogen electrode is constructed. Okay, and yes, so this standard hydrogen electrode, students, it acts as both cathode and anode. Always you have seen that in a galvanic cell, I have told you that there will be a separate half cell which acts as anode and a separate half cell which acts as cathode. But in a standard hydrogen electrode, it itself acts as cathode also, it itself acts as anode also. It is a very unique type, right? And thus the name given to it is the reversible electrode. because it acts as both cathode and anode. Okay, that means oxidation will take place also, and reduction also here only it will take place. There is not necessary for another half cell, right? So we will see how oxidation will take place. See, for the oxidation, what will happen, this hydrogen gas, okay, which we will bubble, will change to the H plus, 2H plus ion, and giving out 2 electron. Okay, so this H2 gas which will pass through this platinum wire will get absorbed on this platinum surface, right? And you can see that what will happen from this platinum surface, the H2 molecules, okay, here the H2 molecules will get absorbed, and from this platinum surface this H2 molecule will change to the ion, okay, 2H plus, giving out the 2 electrons. So 2 electrons, it will leave H2 and it will H2 plus, and it will change to the ionic form, that means 2H plus. Okay, and this thing will happen on this platinum surface. Okay, so it is acting as the what surface, it is giving its surface for the reaction to take place. Okay, and hence this oxidation of this H2 is taking place, because H2 is getting oxidized to H plus ion, giving out the two electron. So this is the process of oxidation. Okay, and we know that oxidation will take place at anode. Now what will happen when reduction has to take place? So when standard hydrogen electrode has to act as the reduction half cell, what it will do, the 2H plus ion, see, the 2H plus ion which are generated will go into the solution, this beaker you can see. So the 2H plus ion which are generated, okay, from this H2 gas will go into this solution. Okay, so these 2H plus ion will accept the electron, because you have seen that the H2 gas has left electron while changing to H plus, right? So these, when reduction will take place, the 2H plus ion from the aqueous solution, okay, because here H plus ions are there, right? We have taken what, 1 molar HCl solution, so from there H plus ions are there, right? So that H plus ions from the solution, what it will do, it will come to this platinum surface, right? It will accept these electrons which are left over by the hydrogen gas, and it will change to H2 again. Okay, so this is the product process of reduction. So this standard hydrogen electrode, it also oxidation occurs how, when H2 gas changes to H2H plus ion, leaving out the 2 electrons. Okay, now in the beaker also H plus ions are there. Okay, so when reduction has to take place, this H plus ion from the aqueous solution, it takes up the 2 electron from the platinum surface which was left out by the H2 gas. Okay, and it will change to the gaseous form, like the H2, again it will form H2 gas. Okay, in this way the standard hydrogen electrode, it is acting as both a cathode and as well as anode. Okay, that means oxidation and reduction in the this very cell only is taking place, you can see. Okay, so this was all about the functioning of the standard hydrogen electrode, and already I have said you that for the standard hydrogen electrode is assigned a zero electrode potential at standard conditions. Standard conditions you have seen, 298 Kelvin, 1 molar concentration, and 1 bar pressure. So the standard hydrogen electrode is given a potential of 0. Always it is by definition only, it is kept at 0 volt. Okay, so this point is very very important. And the last thing which I want to tell you is the representation, because in the galvanic cell also I have told you how to represent a cell is very important. So how do we represent? So we will write platinum first, because the electrode taken is platinum, Pt, then we will write comma, and then we will write the H2 gas. Okay, because the here the metal which we are taking, uh, yes, the electrode we are taking of platinum, right? And in that platinum electrode, what we are adding, or what we are passing, H2 gas. So we will write platinum and then comma H2 gas, and then we will give a line. Okay, and then we will write the electrolyte. So what is the electrolyte? It is H plus, and we will write the concentration also, that is 1 molar. So in this way we will represent the standard hydrogen electrode. It is very easy representation. The platinum hydrogen gas will be on the left hand side, okay, and the H plus will be on the right hand side. Always, you know, this is the anode part, the left part, and this is the cathode part, the right part. So this is the representation. So this was all about the standard hydrogen electrode, how it is made, and what is the function of it, and what is the potential difference of it, right? I have explained you how it acts as cathode also and anode also, right? So I hope this video helps you, right? And any queries you can just ask, you can write your questions below and you can ask me. Okay, thank you so much.